Bluetooth control. And then since it's an IoT device, it's meant to sort of mesh together as, you know, one or many devices. So you're seeing this little GIF up here. If you needed to, you know, compound many effects for, say, a room scale or warehouse scale environment, that could be done. I have not yet gone to that level and learned those lessons yet, which I'm working with a few VR arcades on my own time and trying to learn those lessons. The other thing I can do is there's a Mongo database on board on the Raspberry Pi, and that's becomes really useful when you're syncing simple variables like the 9 degrees of freedom for including scale and rotation and position for objects, say in Unity, that you wanted to synchronize across maybe a tablet that's controlling a virtual environment or something like that. So it's kind of nice to have just a local server on your network that's not out in Mountain View, California, or Unity in Denmark, or wherever they have their servers. It's not necessarily like a multiplayer server, but it's a nice way to synchronize data. And then there's the Unity side of things. So what you're seeing here are basically the 3 overview steps to integrate with my controller. So you do calibration with the native VR tracking system. I've done this with a Cave, done this with the Vive, the Steam VR stuff. I've done this with the Oculus integration, and that's about it. I'm working on the Quest right now, which is a SLAM-based tracking system, understanding the topology of the room. So it's the track space is not necessarily cuboid. It's sort of got a different shape every time. So that's more challenging. And then here in the middle, what you're seeing is after you've basically mapped out where all your effects are, you're assigning them to the 6 sides of your typical track space. So this is, you know, similar to how surround sound is done on a basic level, which is just you're directionalizing where these devices are in the real world to where they should be coming from the virtual content that's locked to the real world. And that's a requirement, is the content does need to lock around the track space. The track space shouldn't rotate. So that's some limitation I introduced that's sometimes problematic for folks. And then on the right here, you can see sort of arbitrary effects. So imagine, you know, one of those fire effects is the dragon's mouth when it's blowing fire. And you can set ranges, intensities, things like that. And yeah, I can answer more questions on specifics later if you're interested. The Unity integration is open source, so I have that up on GitHub if you're willing to take a look at that and my giant walls of code, because I'm somewhat inefficient at Unity programming, but I'm getting better. Oh yeah, and raycasting is how the decisions are made. So the effects themselves they're always raycasting at the user, and that's what you're seeing here on the right. So the experience when I first started designing, I was like, I just need a tech demo because this controller is sort of soaked up a lot of my time and energy. I just need to show it off as far as what it can do, so I can sort of work with other creative developers and learn from them. Feedback is, of course, my main currency as I do this, is gaining feedback from people that try it or people that work with it and develop with it. And at Disney, they have a ride called SOARIN, and my wife and I were married at Epcot, and that's where SOARIN is. And she said, why don't you just follow the format of SOARIN? It's really basic, but it's a compelling experience. You have classical music while you're on a hang glider and you're flying through different environments, and it just jump cuts these environments, and there's smell, there's wind. And it's like one of the most popular attractions in Epcot and in Disneyland. So I did follow that format, and I picked 4 environments. So this is an integration of assets. I didn't necessarily model all of these things. I arranged some of them. I bought piecemeal assets off the Unity Asset Store, used Turbo Squid. I reached out to students at IU. I paid the students to build me assets. The dragon itself was created by a student named Thomas Salas. He rigged it and modeled it for me in a semester. So he got semester credit and some money from me, so good on him. And what you're looking at for these castles is from a Danish studio. I actually forget their name. They're in the credits. But just amazing work. They've got all the level of detail all taken care of. And I highly encourage you, if you just need an environment, to just look out at what studios are doing and putting up for sale. I think I paid $45 for the 2 castle environments, and they're so elaborate, including furniture inside the castles. So what you're seeing on the right there is a state manager. So I made use of Unity's public variables to make my own interface here to manage the lighting, the global lighting, the illumination, the specific assets and sounds I needed to turn on and off. One of the choices I made when I was making this was to put everything in one scene. So if you're familiar with Unity, you can of course have different scenes and then you can load between them. Now, by doing that, you're basically taking things in and out of memory when you do that. So you get loading screens often. And we're running this on like a VR PC. So, and there's tons of memory on most of these machines, like 16 to 32 gigs plus. So I did some testing where I just loaded up a scene with just tons of assets, and turns out I don't need to switch scenes. It was just good to have everything all in one, and then I could toggle between them. Then I don't have any loading screens, and the experience just snaps from one environment to the other. And I'm literally just having a parent object be the entire mountain scene, a parent object be the entire Arctic castle scene with like hundreds of assets below it. So the vehicle design was a lot of fun. So I did do some Unity physics with this. So it's included with a rigid body, which will give it gravity and sort of collision detection if it has a collision detection object on it. And I built a balloon forces script, which stabilizes it in flight in terms of it just kind of giving it a effect of heat in the balloon. And then when you pull the blast valve, it does add force upward so that you get this sort of sensation of you controlling the balloon's lift. Now, I didn't necessarily match the mass of the balloon to a real balloon. I just arbitrarily used just the one, just the mass of one, which I can't remember what the units are. And gravity is how you go down. A lot of people ask, how do you make the balloon go down? It's not really necessary to sort of force the balloon down, because in my testing of that, I found that folks would crash the balloon like on purpose, just get up a little bit and then just force it down to the ground. And I have an experience I want people to kind of go through. And if I have to constantly be resetting or writing in rules into the system to prevent that, you're just sort of like sidestepping potential weird behaviors that users might introduce. So the value discovered, this is the best part of the whole experience, which was as I deployed this and showed this around at different events at the university and beyond, researchers started to come out of the woodwork and ask me to try out different pilot projects. And this was one that was in the intensive care unit at Eskenazi Health in Indianapolis. And what was cool here is the doctor basically said, in an ICU, we're saving people's lives and keeping them alive, and they're here for months. And, we can save every part of their body, all their organs, all the different, functions we have, except we don't really work on their brain and their cognitive function. In fact, that's one of the things that has to happen after they leave the ICU is sort of like cognitive rehabilitation. He mentioned that some crazy statistic, like 80% of the folks that leave the ICU have to sort of rehabilitate their cognitive ability because of the amount of painkillers that they're on and the amount of time they just sit there, stare at the ceiling, and the depression and anxiety that might ensue from being there. So the idea was to give them relaxing content, give them content to make them feel outside of the ICU. And I worked with an informatics student who was building all the environments and taught her how to author VR in Unity. And then the doctor sort of instigated how we would design this for patients that may not have function with their hands. So the interface was optional. Again, the hot air balloon, all you do is pull the blast valve. That's about the only thing you have to do, because most of my users are not savvy with gaming or VR. And then here we have folks that just literally sometimes can't use the handset. So again, a very minimal interface for input. Creativity is sort of the obvious avenue to go down. Here we're on the left, we have a seated experience with smell. So you could smell foods along with wind in this courtyard simulation. I'll cover that a little bit more later. On the right here, you can see different VR systems that we've hooked it up to: tiled walls, caves, seated experiences, standing experiences. I feel like I've taken like this multi-year exploration effort, and maybe building up to a paper or something. So I'd be happy to hear your guys' thoughts on this in terms of what's important to you with environmental feedback. As you notice, there's a lot of equipment around a VR user, and they somewhat have to stay in a relatively small area. Teaching it's challenging, but it's a lot of fun because these students that come and see this system, they become inspired, especially if they are, you know, they already had some sort of vision of something they wanted to make, a video game or an experience in VR. And by just having the Unity integration there, and you know, maybe the 15-minute session of me showing them how to use it, and you see them light up and then build their own content, it's really rewarding to see, you know, your own tool being used like that. So, you know, I continue to just let students see this. I had one student really this funny thing recently. He was trying to build this like dark humor game where like you had to rescue an animal that was in a cage, and it's all cartoon looking. It's not real photorealistic or anything. But if you didn't, there was like this Acme piano, like from Looney Tunes, that was ready to fall on you and the animal. And he had a piece of foam hooked up, and he would actuate the foam so that if you didn't in time, the foam would just, you know, fall on you. But in the game, it looked like a piano. It's something I wouldn't even have considered. And then collaboration has kind of sprouted out of this in a lot of ways. I'm still doing collaborations in the industry as well as at IU. And what you see here is Professor Bernie Fisher lent me a palace on the left there. It's the Piazza d'Oro Palace, part of Hadrian's Villa. And the idea was to do an educational resource. Like what you have, you know, in Roman studies, you have lectures, documentaries, podcasts, you know, all these resources. What if VR, you know, field trips could be another example of an educational resource? And Bernie is, you know, he's doing amazing things in that area with Rome Reborn. And you can sort of get at that on the Oculus Go and the Quest. And then this was sort of pushing the envelope, right? So it was an installation we did at Supercomputing in 2015. And you go through this palace with a narration. There are 360 photos that are mapped to the ruins nowadays. And there was food on a traditional triclinium table. And if you think about it, the Romans didn't have refrigeration. So the scents that we had to put together, a lot of them were fermented smells, things that were smoked, you know, preserved with just heat and smoke. And I had to go to the grocery store and sort of mix smells together. And the apparatus you see up there is what we took to Supercomputing, sort of a showpiece, but it was very compelling. And this lasted for at least 2 years as far as it being a demo that we just kind of kept going with. And then we dismantled it mainly because it was a seated experience. I wanted to kind of move on to these standing VR experiences and room scale. Outreach is just, I mean, it can eat you alive. I mean, if you have a good demo and you're like me, where you like to, you know, show your tech off and talk to other VR developers, it got out of hand a little bit with me because this was compelling enough that I was getting invitations to travel across the country and people wanting to put them in their VR labs. And that's all great and everything. And doing demos around the Midwest is something I don't mind doing, but traveling across the country with all this equipment, that's really tricky. And so we have, you can see down below at IUPUI, that's what we call the reality stage. I'll cover that a little bit more. So that's something that the nearby departments really make use of. So they'll bring students through and say, this is a service Viz Lab that you can use, by the way, if you're doing research, and here are the stipulations on how you get access. And these students are just like eager to go to IUPUI thanks to seeing something so futuristic. So again, the almighty demo is really important to a Viz Lab. You know, I've seen this before with demos that weren't mine, and it's still sort of a principle. So this is the reality stage itself. So the idea here is this is a black box system. You can do something here other than the hot air balloon, of course. You can mount other types of environmental feedback devices, haptic systems, and maybe even supports to mount a physical therapy patient inside. It's just a really sturdy system that lets you just sort of rearrange lighting or tracking systems above the users. And then entrepreneurship. So I partnered with IU as I went along and went ahead and let IU claim the intellectual property on this and I'm the inventor on it. And then now I've got a garage startup company, right? It's the typical American dream, right? Start up a new technology. Thanks, Bill. And start up a new technology and start building it in your garage and then sharing it with folks around you and learning about it. And hopefully, you know, you enter into a new area of the industry. So it's still not clear where this is heading, but I definitely am having a lot of fun. So I'm going to keep going with it. So next steps for me, I have some research interest. I am teaching myself computational fluid dynamic tools like OpenFOAM. I bought some Udemy tutorials, and OpenFOAM is a way to basically watch how airflow occurs over a simulated surface. For CFD analysis, I would really like to learn about how I could record environmental feedback in the real world and then play it back within a system. Basically record and render, much like we do with immersive video. And then, of course, simulation and training, where environmental feedback is integral. So you can imagine a simulation and training scenario for people who have to study or basically are learning what to do during an earthquake. You know, I can simulate that, of course, with shake motors and transducers. And there are folks that have my device at University of Louisiana, where they teach engineers how to service renewable energy equipment out in the field. So they actually want their students in VR with their models, feeling the sunlight or feeling the wind based on the equipment they're servicing. And then creative interest, I would definitely explore heavily outdoor augmented reality in terms of synchronizing real world effects with computer graphics, as well as control. You know, as we do more and more AR, we're going to want to control the real world. And you know, there's other companies, of course, building IoT controllers for augmented reality. Don't want to say I'm the only one doing this at all, but that is an important step in augmented reality, in my opinion, that's really far off, which is cyber physical control. I like to enable people with type 2 capabilities, like maybe just without knowing any programming, equip a YouTube 360 video with environmental feedback through a user interface, things like that. Again, type 2, going back to that graph I showed you. And then also allowing folks to use handsets with AR to maybe map and synchronize content indoors, right? We can do with GPS outside, that's a good tracking system, but if I have my device indoors, I might be able to use it as a beacon. So this is early days for this, but that's one of the ideas I have, which is to use it to sort of extend what GPS can do outside with cloud tracking indoors. So, and then I have invested in some new platforms personally. So I did buy a Feel Real mask, which does sort of head mounted similar things. It does some wind, it does some smell. I haven't gotten it yet. I should get it pretty soon. And then the Tilt 5, this is a projector-based system for tabletop gaming. This is an installation that I could see for, of course, restaurants and public gathering places and things like that. So I want to build a chandelier, an effects chandelier that goes above that will synchronize your game mechanics with the Mongo database, as well as provide sound and effects that go along with the game, totally for entertainment, of course. And then the Oculus Quest is something that's I've invested in. I'm doing lots of projects with that, even beyond environmental feedback. So I want to give a special thanks out to the Eric Wernert and the ABL team. It's an awesome team. They let me entertain my own creative outlet as I also do my day job. So thanks a lot for that. And Bill Sherman let me write a chapter here in his latest book, VR Developer Gems. So if you haven't seen that, take a look at it. There's also several folks here who've written other chapters in it. So kind of a nice CAV related book. So that's it for me. Thank you. If you have any questions, I don't know if we have any time.
We can do a couple minutes. All right.
I don't need that microphone.
Well, it's re-recorded stuff, but I'll stop here first.
Okay, so I think I have microphone already. Yesterday we were discussing that virtual archaeology project. They discussed about the problem with the dizziness because the person wearing the goggles, they are still and then the scene is in motion. Do you have anything similar with your problem, with your demo?
Yeah, cyber sickness is something I design around mostly from content. So optimization is important, right? Running the frame rate that the headset prescribes, and then anchoring is a really important thing to consider. So anchoring is rendering static graphics around your user, like a dashboard or a vehicle base, or like the hot air balloon base is a good anchoring platform. So your body sort of likes that it doesn't move, but the environment around it does. I have heard of people rendering a nose inside of VR just to give that a little bit more anchoring. I always harp on just matching the tech specs and designing for a comfortable experience based on user feedback. So it's not clear to me how to solve cyber sickness in like a magic bullet, but it can be designed around, and user testing is probably the most important way to do that. Yeah. And some people have cited wind anecdotally as helping them, like on an airplane, some people will turn on the little, the blower to not feel so nauseous, apparently. I don't know. So there probably is research on why, wind might help a person feel not so sick. I'm not sure. It might be some sort of a placebo effect, but it's interesting. If there is something there, that would be nice to know.
Your balloon thing reminded me of something I just saw in the Air and Space Museum, which is the pod that Steve Fawcett flew around the world in. It's another balloon-based thing. And I was thinking a lot of the issues with that exploration have to do with cold, have to do with lack of oxygen, different other maybe not haptics things, but environmental effects. Have you thought about those sorts of things in real world? As you go up in a balloon, it gets colder,
Yeah.
oxygen is reduced. Could you design something like that?
Yeah. One of the things that's important, I think, about rendering environmental feedback is it doesn't have to be as accurate to the real world. Now, this is something I will dig into in research to try to figure out if it is important to indeed have, 42 degrees Fahrenheit temperature versus something that just feels cold that's not quite 42 degrees, right? Because our bodies can detect that, but it's just kind of like a very granular, range. It's not, we don't know to the degree of a thermometer, right? Same thing with wind direction. It's like, we just need wind from like a couple directions. You don't need 100 fans, for like optical fidelity is important to have all that. So anyway, going back to your question, the other thing that goes along with that is there is research. If you look up snow, it's a VR environment they use for pain management for people that had they were burn victims. And as they were changing bandages, they would be in a snowy environment. And that was just visually. I have seen people in my demo like literally go like this, and they may just be cold by general, but their minds might be sort of overriding the fact that it's not actually cold, but there's getting some wind and they can see snow around them in the environment. That's sort of my feedback on it. I don't know for sure.
Okay. So I kind of understand how you would have this level of suspension of disbelief for things like a head-mounted display, but I'm a little bit surprised to see things like the Tilt 5 or AR in there, because if you can actually see the fan, then it would probably be a lot harder to buy into it.
Absolutely, yeah.
How are you addressing that?
So the Tilt 5, for instance, if I built a chandelier that's above you and you're always looking down, so it would still be sort of behind you or out of your field of view. The other thing there is it is just an entertainment device. So it's not about right now, maybe later, it's not about realism as much as like an HMD would be. So as I go down that path, I'm going to find out what's important. I think folks having a good time playing a game, they may just want sound and not even any of the effects or just synchronization. So it may not even be a good application, but yeah, I'm early days on that, but I just wanted to share my thoughts on it.
Was fan noise was also similar.
Yeah. Yeah, there's other ways to do wind other than fans. There's a few pneumatic tools that you can use that deploy movement of air. And I'm looking at that for arcades. So when you have an impact, you don't want it to be a gradient of wind. You want actually a pulse. Like there's a toy out there called the Airzuka. It's basically just a thing that holds a large volume of air. And then when you let go, it just compacts it and creates like a fluid dynamic effect. What's it called? Pressure wave. Yeah. So like then you feel this impact as it comes at you. So building some sort of automated tool for that. There is a research paper out there called the Smell Cannon where they do nose tracking and they do the same thing. They have a subwoofer that impacts a volume of air that's scented and they just launch it right at your nose. It's a really cool research project.
We have a really old demonstration of a fire cave back in 1996 in our cave. We show it to people just to show how far technology's progressed. But the funny thing is, when we put it on, the observation you were making about this feedback loop that you really don't know where it's coming from, they see all this cauldron that's burning in front of them, and they hear the flame effect, and then they say, "Do you have a heat system in here too?" And I'm saying, "I wish," but no. So there is something there where you see something and you start feeling hot.
I think optically they have a described phenomenon called the McGurk effect, and it's like your body starts, or your system just starts to map out things you can't see based on the context you have. And I think we have something similar with, environmental feedback. Like if a car drives by me and I hear it and feel the gust, or a truck or something like that, I'm going to assume a truck just drove by me.
So I was surprised how game my brain was, because usually I think I'm fairly cynical, and I observed someone doing their balloon ride first, and I thought, knowing where those fans are is going to bug me. And then, I got on, and my brain agreed to go on the ride. And so it just has me wonder how much of the research, how you control against preperceptions of the technology behind the experience.
I like that.
Because I'm just interested to see who willingly gives it up, who fights to deconstruct the artificial experience, and who goes in not knowing if it's McGurk or, electronic.
Yeah, that is interesting. This is exactly the kind of good work that needs to be done, I guess. And I guess I just need to pick my battles and go that direction. Yeah.
Scott has a question. I got one from our Zoom audience, and then we have to wrap up.
So you mentioned Disney, which is awesome. Two-parter. Have you ever thought of building, hiding the fans or shrouding them with these environments that really make people believe? The other thing is, have you ever considered kind of having a staff of people who are manipulating the environment around them? So once they're in the goggles, it's like it talks about, the people in black leotards on the stage, and their nets, and they're up in the air, and they're like,
like a performance installation.
That's more a commercial ride sort of thing, for entertainment. Have you thought about those things?
Yeah, absolutely. And there's even students that are as crazy to think that they could orchestrate drones to mount the environmental feedback devices on. And I'm like, oh my gosh, that's cool to hear that they're thinking along those lines. And I can't imagine having drones fly around me while I'm wearing an HMD, especially if the rotors are exposed. But moving stuff around the user, there's robotic arms. Again, we're going down this road of extra complexity, and the value is not clear, right? If you add a lot of investment and a lot of complexity, they have to be managed. It has to be maintained and all this. It sort of kills itself when you add too much complexity and cost. And I mean, for a single installation, like at an art show or something like that, I could see that happening. And I guess I'm more industrial and minded, and I kind of want to build an installation that just kind of lives on, on its own without my orchestration, if possible, just like an industrial machine would.
One last question, Chauncey, from the Zoom audience. Do you see Pipes being able to interface with standalone headsets like the Oculus Quest?
Oh yeah, absolutely. The SLAM tracking system is my biggest challenge, but it also introduces an opportunity for me. I was sort of lazy in choosing the Steam VR track space as a cuboid with 6 sides, but now I can start getting into some interesting mapping algorithms and try to create an assignment engine where your real world effects are mapped to a much more granular grid around you. So based on sort of any case scenario of your track space, whether it's 3 meters by 3 meters or 25 meters by 25 meters, which is what the Quest can do if you have the space, how might I map that? And then what sort of recommendations do I make for things that are super far away? The other thing I thought of is, what if you just did small subsets of the same exact environmental feedback capability in zones, and then basically those all operate the same way, but they kind of get toggled on, and they're all capable for directional wind, directional heat, directional smell, things like that. So lots of thoughts. Nothing I can show today, of course.
All right. Thanks again, Chauncey. So our last speaker